Welcome to Mr. Sou's Math World. Today we are going to discuss the thing what is called measures of dispersion. So what is this? Okay. So dispersion actually it refers to how crowded the thing for the data it looks like. Okay, so these two they are different. Okay, so this one it is less dispersed, which means more crowded in English, but math it calls as dispersed. Measures of dispersion. Okay, more crowded. So for this set of data, it is more dispersed, which is less crowded. You see they are more separate, okay? But look at the graph like this, cannot help us to calculate in math of how dispersed it is. So we will introduce the term range and interquartile range for the calculation. So please spend a few minutes to complete this activity. You can find it in page 9.6. Let's check the answer. So for the mean, median, and mode, we can see that all of they goes to 7. But you can look at the data. So for this one, you can see many of them comes from 6 to 8, but from FLIP-B, you have 3 and 10. But for all these median, for you have learned it in Form 3, they are called the central tendency. Central tendency means how middle it is, the 3 averages we have learned before. But then we cannot see which one perform better. So therefore, there is question 3 in the textbook. Okay, so this time you can see we use some dot plots to help us. So this one is less dispersed. That means more stable for A. Because all these only comes from 6 to 8. So FLIP-A is more stable. So in contrast, the results of FLIP-B is more spread out, that means more diverse. So as a result, it is difficult to say whether A or B is better. So it depends on how the competition looks like. So in part A, the competition only counts for the search with the highest score. That means the one which is more spread out is better because only the highest reserve need to be chosen. But if total score are calculated, then FLIP-A is more, looks like it's better because it is more stable. So these are the concept of it. But how to do calculation? We will use the term range to help us to check which one is more diverse. The range is defined as maximum minus minimum. That means we only look at the highest one minus the smaller one with unit. At this time, the question we don't have unit. As a result, the range of the score of FLIP-A is 8 minus 6, which is equals to 2. And then we look at the range of FLIP-B. For FLIP-B, maximum score is 10, but minimum is 3. So this is the range. This is the range. So you see the range of FLIP-B, of course, is larger. The calculation is shown as the box. So you see that the range of FLIP-B is 7. But then for the of A is just 2. Alright? So that means we have the range of A is less than the range of B. As a result, athlete A has a more stable performance. Right. If you want to present better, of course, you can write it this way. So in this way, the presentation is very clear. Calculate the range of athlete A and B, and by comparing their range, you can see athlete A's performance is more stable. So in the textbook, you can see some sort of example for it. Okay. But remember, when you check for the range in the question, please sort the numbers in ascending order if you get many. But this one, it is still not difficult to see which one is the maximum, which one is the minimum. Then you can just check the value one by one. Okay, so in this example, we can see that from you are asked to find the range. That means maximum minus minimum. Let me use two colors to represent it. Maximum, I use the red one, and the minimum, I will use the blue one. Okay, so for brand A, maximum is $7,800. Brand B, you will get $5,900. Maximum minus minimum, right? Minimum, first one, 2,500. Second one, 2,200. And then when you find the range of prices, then just check it out one by one. And then, which one is more diverse, then with this time you can use the range to help you. More diverse means with a larger range. Simply check which one got the larger range and you can get for the answer. But if it's in group data, the range is a little bit different. Because for group data, they are already classified in groups. You see the groups like 41 to 50, we get 4 of them, and then 9 of them calculate the value from inside 51 to 60, something like that. But the problem is, I don't know the value one by one. So what are these? Which 9? 51? Don't know. 54.2? Don't know. 60.4? We don't know. When we don't know for it, then we will use the concept of class boundary to help us to do so. Class boundary means the value we use to plot the graph. Do you still remember this kind of things we have learned before? This is a bit not in proportion, but it doesn't matter. So, the range is defined as the upper class boundary of the last interval. That means we will get the value which is representing the box. But for the box, it is not 71 to 80. Do you still remember for the class boundary, for example, the middle one, like this one? Do you still remember how to find it? The way is to get the sum of them. 670 plus 71 divided by 2, and you will get 70.5 kg. And then for each pair of the bar, okay, that means for each bar the length will be the same. So how to check? It's not difficult to check because you can see it is 61 becomes 71, 51 becomes 61. Then for the class boundary, it also have the same length. So for the what's so-called length for this one, we add 10, right? Every time we add 10 here. So that means for the class boundary, originally this one is 70.5. Then we add 10 for it, and it becomes 80.5 kg. Okay, 80.5. So 70.5, and it goes subtraction, and so on. So that this one will becomes 40.5. We want it again for 40.5. So you can see for the range, it will becomes 80.5 minus 40.5 because we are using the graph method to help us to find it. Using the histogram. Remember, it's not bar chart, they are sticking together. So the range means the length here. The range means this. Finally, let's look at one more example of the textbook. It is in page 9.9. So you can see that we use different histogram to show the distribution. Alright, so our first target is to find the range of the lengths of each of them. And then to find it, we have to mark the two positions of the histogram. Then it is not that difficult because we can find the length of the bar here. So what's the length here? So for each time is 50 to 54. That means every time we get plus 4. That means the interval for each bar is 4 units. 4 each time. And then if you want to get the 2 red points, that means we just need to add half of the bar. Half of it is 2. Can I make it larger? It's 2. Because it's half of it. So that's why in this histogram, it can help us to find it to get the lower part of the class interval, class boundary of this set of data, and then the larger one plus 2 here. So you get 56.5. All right? So calculation is the same as what we have done. So similarly, we do it for group B. So for group B, we also get 4 as the length of the bar. The interval is 4, and then half of it we will get 2, and the highest bar boundary and the lower one are 60.5 and 36.5 respectively. As a result, the range of length of baby in group B is 24 cm. Okay, so for part B's comparison, you can do it yourself. So in this session, I hope you can understand the meaning of range. Especially for this kind of cases, don't forget to find the upper class boundary and the lower class boundaries first before you calculate for the range. That's the end of Mr. Sou's math world. See you next time.